about being able to add, subtract, multiply, and divide imaginary numbers. Let's just talk through some review. If we're dealing with imaginary numbers, this is a complex imaginary number here, complex number. We said that we could add it and subtract just like any normal problem. So here I could just add 1 plus 3, that gives me 4. 2i plus 4i, that gives me 6i. I am done. That is all you have to do. It's just I is just like a regular variable. If we start multiplying it and we get I squared, then remember I squared is equal to -1. So we have to be able to rewrite that. Now, if I have a problem like this, remember it's really a -1 in front of here. So I'm gonna change these all. So I have 2 plus -7i. I do not like subtractions. Plus, and then I'm gonna change that to a negative. So if I multiply through here, I get -1 times 5, which is -5, plus -1 times -3i, which is +3i. Now I just add just like normal. 2 plus -5, that's -3. -7i plus 3i, that gives me -4i. Another additional one, so 7 plus 3, that's 10. -4i plus -1i is -5i. So you can add and subtract imaginary numbers just like it would any other variable. It makes no difference. Now when we start multiplying, there's a big difference. Because remember, we talked about the square root of -1 is equal to I squared is equal to -1. All right, so if I multiply, so 2 times 3i, well, that's just 6i. Not a big deal. If I multiply here, I just distributive property, just like normal. So this would be 12 plus 16i. This one's going to be a little bit more complicated. If I multiply through here, 2i times 3, that gives me 6i, plus 2i times 5i, that is 10i squared. Well, I squared is -1, so this is going to be 6i plus -10. And there's my answer. This one here, I have to do FOIL, so 1 times 2 is 2. 1 times 5i is 5i. 2i times 2 is 4i, plus 2i times 5i, that is 10i squared, which is -10. So if I combine this together, I get -8 plus 9i. Now, if you have a problem with that, if there's something that you don't understand last week, please come to Monday's live session, and we can go through any problems that or any questions that you have on these things. This week we're going to be talking about other types of equations. Okay? We are going to be solving polynomial equations every 3 or greater. Oh boy, we used to solve polynomial equations of like x squared, but now we're going to talk about equations of degree 3 or more. We're going to solve radical equations, and we're going to solve rational equations. Oh boy, if I was doing this in Algebra 2, each one of these concepts would be a week's worth of work. However, this is pre-college. You guys should have seen all of this stuff previous to this class. Hopefully, keeping our fingers crossed. If not, please come to Monday's live session. We can always go through as many problems as you want. Polynomial equations. In this section, you will extend the techniques for solving equations to nonlinear and non-quadratic equations. At this point in the text, you have only 4 basic methods for solving nonlinear equations: factoring, extracting a square root, completing the square, and the quadratic formula. We did that week 3, I believe. So the main goal in this section is to learn to rewrite nonlinear equations in a form to which you can apply one of these methods. Example 1 shows how to use factoring to solve a polynomial equation, which is an equation that can be written in the general form an xn an minus 1. So you write it from highest power to lowest power. That's what they're trying to get at. When you write a polynomial equation from highest degree to lowest degree, that's what you want in order to work on that problem. So the first thing we're going to do is we're going to solve a polynomial equation by factoring. Well, remember, in order to solve a polynomial equation, like if I had 3x to the fourth minus 48x squared, I have to get it equal to 0. So the first thing I do is I just rewrite this as 3x to the fourth minus 48x squared is equal to 0. And then I factor out the greatest common factor. Well, it looks like I can factor out a 3x squared, doesn't it? So if I factor out a 3x squared, I'm left with x squared minus 16. Oh boy, I'm still not done because this is the difference of two squares. So then I have a 3x squared, x minus 4, x plus 4. Now I know that since the highest power of this problem was 4, I know there's 4 solutions. Well, positive 4 is a solution. Negative 4 is a solution. And then if you ever have an x on the outside, 0 is a solution, but this is x squared, so that means 0, 0. I have 2 zeros as solutions. So my 4 solutions to this problem are positive 4, negative 4, 0, 0. Now, you don't have to write both zeros. It makes no difference. But you have to realize that if you factor out an x, that 0 is a solution to the problem. A common mistake that is made in solving an equation like this, in example 1, is to divide each side of the equation by the variable factor x squared. This loses the solution x equals 0 because now you don't have any x squared when you solve it, when you factor it. So do not divide each side of the equation by the variable because that will get rid of 0 as a solution. Okay. Occasionally, mathematical models involve equations that are of quadratic type. In general, an equation is a quadratic type, can be written in the form ax squared plus by plus c. Okay, this is quadratic, and if it is quadratic, you'd solve it like that. But now, let's say you have 4 terms instead of 3 terms. A quadratic formula works when you have 3 terms. We're going to be solving, or we're going to be factoring with 4 terms. So we're going to have something like, x to third plus 4x plus, or 4x squared plus 3x plus 2. There's 4 terms here. You can't use quadratic formula here. So what we're going to do is we're going to solve this by grouping. We're going to group the first 2 terms together. We're going to group the second 2 terms together. That's why it's called grouping. And then we're going to factor each of these. Well, I just made this up, so I wasn't thinking when I did it. But that's how we're going to do it. So we're going to factor first. We're going to factor out we're going to group 2 terms together. Then we're going to factor out the greatest common factor. And if the parentheses has the same thing in it, then we can factor that out. And I'll show you an example. So here I have x to the third minus 3x squared plus 3x minus 9. Step 1, group 2 terms and 2 terms. Second step, factor out the greatest common factor. So x squared is greatest common factor of the first parenthesis. So that gives me x minus 3. And 3 is the greatest common factor of the second parenthesis. So I factor that out, I get x minus 3. Look at this. This is where, if these 2 parentheses are exactly the same, then grouping works. So now my last step is to factor out that x minus 3. So if I factor x minus 3 because it's the same in both terms, well, what's left if I factor out an x minus 3? I'm left with x squared. What happens if I get rid of x minus 3 there? I'm left with 3. So this is the factored form of this whole thing. And how did I do that? I did it by factoring by grouping. So if there's 4 terms in a polynomial function, the first thing you want to do is you want to try to factor by grouping. All right, that's an awesome way to factor. And here's the work a little bit more. And they solved it. So one solution is x equals 3, and the second solution, I'd have x squared plus 3 is equal to 0, so I'd set that equal to 0 and solve that. Find all the solutions of the equation, check your solution. Okay, 4 terms, awesome. 4 terms, step 1. This is where it gets a little tricky. I'm going to put that minus sign and make that a negative x, okay? Don't leave that as a minus sign. Trust me, it's going to mess you up. So now I'm going to factor out the greatest common factor, x squared. So if I factor on x squared of the first parenthesis, I'm left with x minus 5. Plus, I'm going to factor out a negative 1. Why a negative 1? Because look what is left. I do that, x minus 5. These 2 terms are the same. So I'm going to factor them out. I'm going to factor out an x minus 5. What's left? X squared minus 1. Well, x squared minus 1, that can still be factored. That's the difference of 2 terms. So this thing factors down to x minus 5, x plus 1, x minus 1. Amazing. Solution, 5, negative 1, 1. 5, negative 1, 1. I'm going to go with letter D there. Awesome factoring. Now, I know I talk fast. It's just the way I am. if I go too fast for you, guess what? You can always go back and rewatch it. You can slow it down. I would definitely go over the problem, try to do it by yourself, and then go on and then watch the recording and see if you got it right. So that is solving polynomials. Next one we're going to be doing is we're going to be solving radical equations. A radical equation is the equation that involves one or more radical expressions. A basic strategy for solving a radical equation is to isolate the radical term first. So you want to get the radical on one side and then raise both sides of the equation to the power, remove the radical. So if I had something like x plus 2, the square root of x plus 2 is equal to 7. This is isolated. There's no numbers or outside of the radical that I have to get rid of. So now I would just take both sides to the second power. And I'd end up with x plus 2 is equal to 49, and then I can solve that out. Now, if this was the third root, okay, of x plus 2, then I would take both sides to the third power, because the third power gets rid of the third root. So that is one of those things that, you know, everybody thinks if there's a radical that you just square both sides. Well, you know, sometimes it's a third root, fourth root. You have to make sure you understand what root it is. Okay, so if I had a problem like this, ooh, this one's not nice. Huh. All right, first thing I want to do is I want to isolate the radical. So I'm going to add an x to both sides. And this is why it's not so nice. I'll show you. So now I have x plus 2 on this side. Now I'm going to square both sides. Well, that's where it gets to be a little, you know, that means I have to do FOIL over here. So this side, that just crosses out. I'm left with 2x plus 7. That's easy. But here, I have to go x squared, x plus 2 times, because it's squared, so I have to FOIL. So that gives me x squared plus 4x plus 4, doesn't it? And then in order to solve, I'd set one side equal to 0, so I'd subtract x off of here. So this would give me x squared plus 2x. I'd subtract 7, so that would be minus 3. So this side is equal to 0. And then I look at it and say, can I factor that? So that gives me x plus 3x minus 1. So my solutions are negative 3 or 1. So it started off to be a really hard problem, but after I went through it, it's like, oh, that's not so bad. But when you have a radical, what you want to do is you want to isolate that radical on one side and then square it or take it to the third root or whatever it is. And here's the work that they have. Probably done a little bit nicer than I did, but find the solution. Well, it's already isolated, so I'm just going to take the second, I'm going to square both sides. So I end up with 2x equals 16. Divide through by 2, I get x equals 8. Find all the solutions. Okay, now this time there's a couple things on the same side that the radical is. So I've got to get rid of that 9. So I've got 12, the square root of x minus 9 is equal to 0. So I'm going to add 9 to both sides. I want to isolate the radical. So now I've got 12, the square root of x equals 9. I'm going to divide through by 12. I want to get the radical by itself. So now I have the square root of x equals 9 over 12, which I can reduce to 3/4. So now I'm going to square both sides because the radical is isolated. So I get x equals 9 over 16. And there's my solution. All right. So that was radical equations. Now we also have rational equations this week. Okay, solving rational equations. So a rational equation, one second, I have to turn this off here. Okay, so a rational equation, and we've solved rational equations already. It's just kind of has fractions on the bottom. We're going to solve exactly the same way. We're going to multiply by the lowest common denominator to get rid of it. Okay, so if I had a problem like this, 2 over x equals 3 x minus 2 minus 1, I'm going to multiply. Now, some kids are going to say the lowest common denominator is x minus 2. It's not. The lowest common denominator is x minus 2. So I'm going to multiply every single term by x minus 2, x minus 2, x x minus 2 every term. So what happens here is the x crosses out. So I'm left with 2 x minus 2 over here is equal to, well, here the x minus 2's cross off, so I'm left with 3 times x minus, and here nothing crosses off because there's nothing in the bottom. So that's I'm gonna multiply this through. That gives me x squared minus 2x, right? But I have that minus 1 there. So it's really be negative x squared plus 2x. So now I have an equation. It no longer is a rational equation, and that's what you have to get out of this, is you want to get rid of those rational equations, because that helps immensely. So now I can solve the rest of this, and I see the next slide solves it. So instead of me trying to squeeze this in, I'll just show you down here. Okay, so they multiply by x minus 2. This is what they're left with. They're going to get, it's a quadratic, so we're going to get everything set equal to 0. Then we're going to factor. Once we have it factored, our answer is pretty easy. It's just 4 and negative 1. Okay, so the rule when you have a rational function is multiply through to get rid of that denominator. Okay, so let's take a look at this problem right here. I'm going to multiply everything by 7x plus 3. Okay, so that's my common denominator. So I'm going to multiply this by 7x plus 3. I'm going to multiply this by 7x plus 3. And what happens here is the 7's cross out. Oh boy, that's not going to be nice. I'm going to be left with x plus 3, x plus 4, minus, and then here the x plus 3 is going to cross out. So I'm going to be left with 7x plus 4 is equal to 0, because I would have to multiply by over here, but 0 is going to, anything times 0 is 0. So I still have a ways to go. I'm going to multiply. I'm going to do FOIL here, so that gives me x squared plus 7x plus 12 minus 7x minus 28 is equal to 0. I'm going to combine like terms, so I've got x squared. Oh, the 7x's are going to cross out. I like that. And then that gives me what? Negative 16? Oh, I like that. That's difference of 2 squares. X plus 4, x minus 4. So my answer is plus or minus 4. Wow, that one turned out a whole lot nicer than I thought it was going to when I was multiplying it out. But you just have to, you know, the rule is get rid of those denominators. Because once you do, then it just becomes a regular equation to solve.